Welcome everyone to another live Linux kernel developer live stream here on our low-level code YouTube channel. So today, starting to modify the Linux kernel, port the Intel ironically i915, still named after the decade-old iGPU, to ARM and RISC-V. We have done this previously with RDNA2, right? Previous video there, unmatched RISC-V. And I thought in the long term, because there's always a challenge of that to work on random ARM64 and even ASI Linux, latest and greatest M1 Studio Mini and stuff, to connect their dedicated GPU with write ordering and stuff, and PCIe mappings and so on. And I thought, why not the usual stuff, right? Developer going crazy and responding to support new stuff. In contrast to popular belief, some Linux news sites a year ago proclaimed there is some RFC patch from Intel, but this patch is complete garbage, right? I wonder, like, how is this an Intel? I mean, you can't even take this seriously, right? Why? Here was a patch of, which again, on at least one Linux news sites a year ago was celebrated as like, hey, some Intel developer patch this to remove integrated graphic for paving the way to maybe use this on ARM and RISC-V. It's like, no, more. So not only does this patch not do that, well, it claims to do that, but the only thing is this is a complete garbage patch, and it's also why I wonder if this is a serious developer or intern, because it is only, or for the most part anyway, here's some bloody detection macros, GP platform and stuff. But so this macros only change detection logic, right? And then the only other thing they remove here is those device tables for i830 and similar such information, i915G and so on. So this patch only, this also wasn't applied, right? Because obviously it's unusable, like no operation. And so they only in mostly a header moves this, so they do not disable code, right? I mean, not only do they not, I tried this yesterday also, there is stuff to do, right? And the porting stuff to do is nothing that was patched here, right? To nobody's surprise, this strange stuff here, that, like, yeah. Anyway, and so also, I mean, ironically, in this patch, they even write, yeah, it's not much smaller. It's like, yeah, if you only remove device tables and not code functionalities, like they're not removed. It's not even a make file and disabling some file of stuff. So yeah, you are, congratulations, you removed some device table. It's amazing. Anyway, so the real stuff we need to do, and I tried this yesterday. So this is basically part one. This is assessing the damage, because there's lots of x86 brain damage here. The first thing we need to do to enable this driver, which is in driver GPU DRM i915, either here or in the, I think it was here. So first we need, so currently the Linux kernel using this kconfig stuff, and this DRM i915 depends on x86. And so then, what caps lock? So we need to remove that to even enable it, right? So currently the code cannot be selected, it cannot be built, because it's depending on x86. So let's say, okay, let's depend this on any platform that has PCI support, which is what that is for. We would need to check what this Intel GTT graphic translation table, or whatever that was. It also selects, oh, did I save this not correctly? I was fat fingering live on YouTube. So now the research starts, right? Then we need to kconfig that. So this is RISC-V, right? I want this on RISC-V, but the same applies similar to ARM64, i915. And let's build it as module. Maybe disable as much as we can for now. And let's try to build this. So this will fail. Let's maybe build Linux modules. We build this module. So all the modules usually don't clearly build if we don't have the VM Linux. So this will fail, I know that already because I tried it yesterday with x86 systems, meaning using non-portable Linux kernel internal x86 stuff in this driver. Maybe it is like, let's try that first. So I'm building on Epic Threadripper Ryzen 7 1050X. I'm cross-compiling that, right, as we usually do, because if we would do this on this unmatched RISC-V, this would build a whole afternoon. So in my experience, like you need some like general build infrastructure enablement stuff, or this will completely not build. And then there is some module shortcut to only build some modules, which would be like that. But that also, this is why I pre-built some stuff, because my experience is like, if you do that, not all the dependencies are there. So my experience is usually better, like to just build this stuff when there's some Linux-based kernel symbols and built-in symbol version and stuff. Yeah, that builds quite some stuff. Novo and so on can be. Oh, oops, this is also wrong. Wait, what have I done here? GPU, DRM. Let's shortcut this further because we don't have all day. So we now need to research that there is some stuff here is, yeah. So this I need to check. So what we need to do next is, and obviously it's blowing up in build errors because like in contrast to popular news sites believe, no, there is no other architecture enablement. So the good news is some stuff probably built there. So the bad stuff is we usually don't have PU stuff, right? I had the similar thing with AMD GPU in the Linux kernel, like in my hypothetical microkernel would be different, but in the Linux kernel or other BSD kernels, you cannot just use floating point because mostly for performance optimization. Theoretically you could, but then you would need to always save all the floating point state, which on a 386 was expensive, which is why today we still don't do it. And nowadays, even with AVX 512 and stuff, it would be expensive, or even AVX for that matter, because there's just so much register state, right? There is only floating point enablement for x86. Like you need to explicitly enable it. Like enable what? There was some function name, enable FPU, enable whatever that was. Maybe we see it even here. So basically, we would need to. What do we have? RISC-V implicit declaration of page align. That is freaking included from. That is so. This should be so. Page align and shift should probably be easy to fix. So I'm on type name. So I would actually maybe ASM set memory. So I would maybe say the RISC header could also be at blame, but other stuff here is page P, Intel GTT, ppad uncached. So yeah, so we need to review each of this, starting with this header. This might be a relatively easy thing. This on a first glance just looks like maybe this RISC-V ASM set memory header is not safe to include without some other includes. Set memory, ASM set memory. Do I have this copied? Maybe. Oh, I copied the one. Does it include ASM? No. Arc RISC-V. Set. Yeah, maybe I should only. There it is. Not memorize it. So config MMU. What do we have here? Page. I would, and that is the thing, right? With each of those changes, I would need more time to review what is the Linux kernel style. I would personally, I mean, on x86 you could include the x86 header for that. So like if I send in some patch, so basically we need to include something. Actually, we could theoretically check what the x86 header is doing there, which should be the same name. Okay, there's ASM page. It doesn't sound too bad, does it? Let's see. So I'm working in our T2, one of the most amazing Linux distributions, sandbox build environments here, right? This is why I have this fix file so that our just helper shell script aliases here and functions can be used to diff that. If not diff assembly, then probably that. Let's see what we get now. It's just some random guesses, right, of 20 years of experience. Did this fix? Maybe not page align. Okay, this did not so much to random guesses. The next best thing actually, let's see where this is coming from. Set mem processor, page align, define task, unmapped base. Okay, so it's also not coming from there though. There is some define page align 9 maybe. Where's the x86 one? Oh, USVI probably. Memory. What do we include? Okay, this is Linux. It's actually okay. This was. Then let's try that one. I'm a little bit surprised. Always like this are very basic things that no other Linux driver included. Some memory thing that this like didn't blow up previously with missing things. Okay, I guess we got one further. Or did we? Wait, maybe I didn't. Oh yeah, yes. I think this built now. Okay, so memory 26. This might be a larger showstopper. I mean, also I should mention, if you're new to this stuff, it is only it looks relatively easy because these are relatively these are the easy things. Right, today we do the early damage control assessment here, and also the Linux kernel is written in C, not in assembler, like you do for 40 years. In higher languages that could be even easier, and it's not like virtualization or other low-level stuff, so that is a relatively high-level driver which only does a little bit of x86 trickery. So let's see what they do here. We could for a check, I mean, they probably enable FP somewhere. FPU. Ah, here, kernel FPU, so memory. What is that even freaking doing? Memory NTDQA. Okay, that sucks majorly. So they're using MMX registers, also used for other, so move APS. So this is why do they do that? So okay, so this obviously, so this is assembly. So much a minute ago I said we're not using assembly, and then 1 minute later, Intel developers hold our coffee beer. Let's do assembler. So this is why, as expected, they need kernel FPU begin. As I said, normal monolithic kernels don't allow that. The problem is we don't have that for all architectures. In the Linux kernel, we only have this for x86. Maybe in the meantime PowerPC and maybe ARM, not for RISC-V. I started that enablement for RISC-V 1 or 2 years ago with my popular AMD RDNA2 on RISC-V. So I have an experimental patch that's not finished, but neither AMD nor Hi5 Sci5 wanted to pay me $2,000. I no kidding, only asked for $2,000, and all those companies like, yeah, sounds great, we have no budget for that. So if you need a RISC-V FPU enablement, I have some half-finished patch lying around. Because it's not so easy, it's a little bit tricky, right? Devil is in the details, and you need a day or two to properly implement it and test it and so on. But yeah, my half-assed patch works well enough for RDNA2 graphics on RISC-V. So yeah, we would need to accelerated aligned read from what is WC write combined? Is that write combined? Copies long bytes from Non-temporal instructions were available, not at all arguments. So were available, so what do they do here? Static branch lightly has. Okay, so they do move anti-DQA, also amazing complex x86 instructions, right? We could. So this is some whatever NT was, and then quad whatever. I don't use it daily. I start to forget this complex x86 nonsense. Long double and non-temporal. Of course, NT stands for non-temporal. How could I forget this? Probably done too much RISC and PowerPC last and Spark. So yeah, move, non-temporal, double, quad word, alignment. We probably can replace this with generic. Probably. What do we have? WC should be right combining, right? We document this. We see from tested and perform an accelerated line read from. They would just. Yeah. So. Okay, init early. So basically, how do we do that? And so yeah, this is a more real porting. So although there's a C, obviously this stuff is only available for x86. So as an early porting stuff, so we would need to further review if additional memory guarantees are needed. Copy from I would think it should just be slower, which YOLO don't care. And so if they have all of this stuff x86 and otherwise just replace it with a plain old mem copy. What is next? So we need to do this later. So page, what is PWT? PPAD. So physical address extension probably. Right, with what was it now? WA. Where was it? Pad, whatever. Define Gen A. What do we have here? Gen 8, 32 byte style address, 32-bit style. Oh no, bit. 32-bit style address. Also pro tip if you mean bit. Ah yes, okay, 32-bit and 48-bit. Style address is defined as 4-level page table. So page P, so this is probably, let's see where it's coming from. It's probably x86 specific stuff in Arch x86, just with R. By the way, I think PAT was page attribute table. Where do we have here? We have page table types. What was it now? PW. Oh, I forgot. PWT. Page write through. So these are the x86 internals of the MMU details. Present, read write, user, write through, cache disabled. So the question is, how do they use that? They probably, let's driver GPU DRM 150. What do they do with that? Page table. So Gen 8. PDE encode level. The question is index shifts into the page table are offset by Gen 8 PTE shift 12. So we want to run Arc and DG1. The question is, where was this now? Gen 8 GT. How many generations do we have here? Gen 8, Gen 9. The question is whether this Gen 8 stuff is also used, because we have a Gen 2. So what hardware vendors usually do, they obviously are not stupid and change everything between hardware silicon. Even in NVIDIA you see NV whatever 80 and whatnot, 100, whatever their architectural encodings. Even in the P3 previous videos, right, RSX, there are decade-old bit-defined things, commands and attributes and stuff. Even going back to maybe NV1 or so, at least kinda. So there, you see this here not for all generations, because most likely they didn't change between. So probably Gen 2 is used also. I mean, speculating here, but obviously there's nothing else. So from my experience, so probably Gen 3, 4, 5 are the same. Then 6, 7, 8 are a little bit different, and probably the page whatever graphic translation table also probably did not change. So we need to make this somehow work. Where do they have? And yeah, I never said it's easy, right? So so that needs a little bit of thinking what they're doing here. So Gen 8 PDE encode. Where do they store this PDE? So they don't store this, they only create this. I mean, it is possible. I didn't, probably I should check. The problem is the specifications, Intel released some specifications for some hardware, and they're usually 1,000 or 2,000 pages. Although probably like instruction set architecture for the unified shaders and stuff, there are probably 1,000 pages, and maybe the more general architecture-based stuff is maybe only 600 pages. Just some random ballpark figures from other stuff I've worked with. So where do they use that? They, oh wait, this is, yes, object encode, it's in the same file. Gen 8 PDE encode. So that is the object encode. So where do they store that? Setup scratch page. What's going on here? Init scratch. Scratch is usually some memory where you write temporary stuff. If everybody agrees to not write into the scratch page, we can reuse it for all VM. Keeping contexts and processes separate. VM has read-only, VM, GTVM. Is GGT, clone, scratch setup, scratch page. I mean, what we could do is do that later. What do we have? Page, print page. Oh, it was this level, was this, this was that here, right? Let's use fix file. We can also, so what a common shortcut is to, if dev0 this for now is a preprocessor, just to see, I basically want to assess how much porting effort is necessary and how much more stuff fails, right? It makes no sense to spend 90% of the time now on such x86 details to figure out later, like hours later, like, dude, there is so much more stuff, it's next to impossible to port anyway. What you could additionally do is print, not in this if0, of course, you could like either also print K, like, not yet implemented. Not yet implemented. And then so you would see, like, if it is even used, like if you boot that already on some RISC-V board, is it even used? Or is it some virtualization, whatever stuff that's being used? So we have more of this stuff here though. Maybe I did this wrong. PPGT, PTE encode. Did I patch that wrong? Or did I wait this present? Okay, let's. What's the other stuff? Page PW, what error define? An expansion of macro pipette uncached 49. Ah, there's more of this. The other stuff probably too, or page P uncached, pipette uncached. What else do we have? Pipette cached, uncached, pipette cached. So again, I would need to review in more detail if they just use the same bits on the iGPU like an x86 processor. Here's also some exchange Intel Encore, an expansion of that error call to compile time assert declared with attribute build bug failed in implicit declaration. So yeah, there is some more. Wait, what is this? Page PCD is also expansion of PTE 52. Oh, that was this one. I wonder if those others. Where do they store that? We'll see later. So here's some compare exchange. Implicit declaration of year 13. Is it still the same file? Intel GGT 1308. No. Wait, must be another file. GT, Intel GT. What was it? Probably should use a more integrated. So flush, that is an x86 instruction. That has a C function there, write back and invalidate cache. This is what is GGT resume? Is this resume VM? Sounds a little bit either virtual machine, or is it, by the way, is this virtualization? So yeah, the next to do equivalent for RISC-V and error compile time assert in Oh, there is more. Ah, right, we had still this one here. Oops, okay. So yeah, let's do this boring memcopy stuff. In a way, it is silly. So I find this open-coded assembly silly. I find it bad style. In my opinion, the Linux kernel. So it's a performance optimization hack for the most part, and I would say after 30 years of the development, the Linux kernel should have. I mean, maybe there are some. I don't know. Every Linux kernel header function and stuff from the top of my head. But in my opinion, there should be some generic memcopy optimized, whatever, cached, uncached, write, combine, and whatnot stuff. Static key false has defined what? Define static key. What is even bug on bug expression? Yada, something. So basically, what is the? Do we have an x86? What is probably config? Should this be defined? Let's grab if this should be defined. I don't do such nonsense each day. Yeah, KVM, so if dev config x86, that probably should cover that. If dev config x86, then all of this stuff. And so init early is probably run somewhere. So either we patch that away there, or we excuse me. Yeah, memcopy init early. So either we have two options. Either we sparkle an ifdef in there, or we create an empty function because YOLO, who cares? So it's like, yeah, nothing to do. Let's do that so that we have, I mean, it doesn't really matter. I would personally do it entirely different anyway. Maybe I should use the same keyboard layout all day long. So memcopy from, so length probably should be, what is something around? I mean, an elegant solution probably could be to simply ifdef that in some header, but for today we just map this to memcopy from WC memcopy. Okay, this is only one function apparently. What do we have here? 16 is aligned address. Yeah, this is so silly. It is ridiculous. Yeah, let's just memcopy test source length. Fine. For production, we probably should research what other optimized memcopies there are. Compilation errors to this stuff. Oh, this is alright. FPU. So unfortunately, there's also this memory age init from online memcopy from. Oh wait, are there two? Did I overlook one? Used SSE 4.1. Just checking for knowledge that this future use will correctly align just use. Can memcopy from Has mem copy from... Wait, they first do that. Has mem copy from what? Mem copy from... What the heck? They run this with the zero links to this here. Whatever, I guess. Yes, so there is false. Returned true if the copy was successful. False if the preconditions are not met. CI continuous integration bug on not has no. What did we want to do? We want config f86. So basically, what else left? Implicit declaration of function. No, mem copy. What is the Linux kernel have for that? Can't make this up. Do they call this just string H like in regular user space? Yeah, so even in 30 years, like in 30 years, even I didn't had to look which header in user space sees it is strings.h. String.h. Okay, they have string.h. Okay, probably the same. So that works. Maybe not. Best without typo. Okay, Linux string H would be too easy if that would be more portable. So I never had to do a search for that because usually it is already like, usually stuff includes stuff that includes other stuff. So usually you have already 100 headers included. It's usually included. So is MTL. So yeah, more stuff built. Yay. To timestamp counter. What do they do there directly with this timestamp counter? Yeah, I find this in general. So for my how should I call this? Elusive vaporware microkernel project. I would completely not want this platform-specific stuff all over the drivers, right? Why in 2023 stuff is not using more portable things, more portable timers, and why stuff is fiddling around here with that, I have no idea. So they also have here CPU info max frequency. So in my opinion, I mean, sure, it previously, decades ago, it was an integrated GPU thing, but and due to the nature, it's certainly quite integrated with, as the name implies, integrated with some CPU, but at least since dedicated graphics, not even since i740 and i840, the original Intel dedicated graphic chips nobody wants to talk about anymore. In the 90s, yeah. Default to measure frequencies. Now, of course, it's only some fallback. So they get this, they try to get this from CPU frequency, CPU get. So what we could do is that the usual, right? If def config x86 and timestamp counter And here, timestamp counter. Where do they measure the default to measured frequency? Okay, so this is probably that one here. And if the config x86, and otherwise we could even bug on, was it that? That will, oops, the kernel. Bug on hypervisor. There is then bug. Okay, there's bug on and bug. So this will give us an oops. I would guess it is, it should I mean, yeah, if we have a CPU frequency policy, which yeah, it depends. We will see if we mod probe this module and it oopses there on bug online, bug online 49 or so. Yeah, and this is why there are all these bugs and bug on in the Linux kernel, because shouldn't happen, and if it happens, then some developer will eventually be notified. So what's more errors? Compilations. I think it's Encore, Intel Encore. Did I do this? I also mistyped that. Did nobody? If the yeah, nobody said Linux kernel development is easy, or we have picked and did the next bunch of stuff maybe built. Error implicit declaration of static CPU has gem domain. There's also, is this the same? No, gem and gem domain. There's also gem. Boot CPU. So if we don't overwrite a cache line completely, we need to be careful to have up-to-date data. But first, CL flushing, don't over-complicate things and flush the entire patch. Partially needs C-flash before partial cache line. Right, I have the feeling need CL flash before. Yeah, this cache flushing should also be somewhat more generic. I mean, most other like SCSI NVMe drivers and stuff obviously usually do stuff. Partial cache line. Shared memory, what is it doing here? Page length. Game object get page, minty length, page size. There is anyway gem domain. So gem domain at least CL flush. Gem domain CPU object. So yeah, this flushing, this will be a pain to get right. I mean, it is crazy that other graphic drivers get to do without this, right? The AMD GPU driver doesn't have all this flushing nonsense. I mean, cache flushing correct, and I shouldn't call it nonsense. Cache flushing correctness. Static CPU has feature. I mean, the gem object set to CPU domain, what cache coherent, and i915. BO buffer object or so, cache coherent for write. So yeah, I mean, yeah, I guess lots of more if there's. Where's the first thing that PAT enabled? Okay, so this we can gem pages. Was it also? We just don't have pet, so one on map write combined. Okay, so this is just one on gem, one on. So yeah, this now sucks. Basically, close your eyes. Linus Torvalds hell hates this. One on type, by the way, does it even work? Because it's a macro. Does the macro work over multi-line? So yeah, good luck getting this upstream. Where does this, wait, this is even here, right? I'm not even sure if this will compile. I forgot if, see, preprocessor macros can spawn multi-line call. So where is that even? Yeah, so much to making it easier to compile on. So maybe that even freaking worked. To get this upstream, I guess the Linux kernel developers might actually I can show you that. So they usually some people freak out about like macros and function calls. So what they probably would prefer more, if you want to have a chance to get this upstream, is if defing the whole line. That would be if def config x86. I personally don't care the most. I would use another language to start with. Oops. But if I really need to use C, then I would personally not have a problem. I mean, I would not use C, but like, if I'm like in this Linux kernel case used to use C, then I would rather avoid this minimal code duplication there in def there if def pet enabled. So yeah, that's then. I have no idea whether this i915 stuff, if it works, then we could of course research the callee and see what it does. But how many more files are even necessary to build this stuff? Gem domain, static key false, SCF flash. Yeah, still have this. Heads are still opened. Some background editor. I would think this one probably should be defined. Yeah, that probably is an independent define. Yeah, we probably looked at this earlier. So, or not then arrow unpin gem and not the Linux kernel developers hate this trick. or not CPU has so cache current for read. So or not CPU has C flush. If you're not in the CPU read domain, set our sets into the GTT read domain and manually flush cache lines if required. This optimizes for the case when the GPU will dirty the data anyway, again before the next P read happens. So I would think it should be safe if we true that, right? Static CPU not has so, or oh wait, if we true that, actually we can leave that here. And CPU, so it does not have some CL flush. Yeah, Linux kernel developers will not like that. More code duplication. So there is, as expected, as I've seen yesterday, this is also why I did this exercise today, assessing how much is... I'm also surprised that the Intel developer have not cleaned this up, right? It's not like the Intel Arc has highest performance and stuff, not that they make it work on ARM and RISC-V and sell more to like Raspberry Pi and other enthusiast non-x86 people. I mean, not like, I understand they don't want to promote non-x86 for still selling the CPUs, but given that there are quite some hiccups with dGPUs on ARM, you have to wonder why they didn't make this more readily working already. So not 740. 710. So, wait, what else do we have here? $710. What did I? Oh, maybe it did 740. Okay, there it is. Okay, this is the same for write. Maybe this will make developers less or true. Close. Leave me in the comments below what makes you more happy. Certainly should be consistent. So current for write or true. I mean, basically it disables the rule test, so that would be what was it? This was x86 feature. Do we have more of those? Apparently not. So which of those do you like more? This. Oh, so may I unpack my US keyboard. So there we have again this VBAR and VD. DG1, oh, this is special here since it will snoop transactions even with cache none. This is not the case with other head snoop platforms. We might need to revisit this as we add new discrete platforms. Consider doing a VMAP flush or something where possible. Can't we just do a heavy-handed CPU series since the underlying SG tails, SG is usually scatter gather. Table might not even point to struct pages, so we can't just call DRM CL flush G or something like so in the driver. I mean, luckily we only want to do that on discrete, so has LLC. And I mean, luckily I would use DG1 first, so we can bug on that. Are we getting there? Yeah, didn't instantly notice, welcome back, that my network disappeared. And it wasn't the bloody Vodafone DOCSIS, it was a bloody Intel i225V that we had to refresh ourselves once. Maybe related to PCIe 80 PSM advanced whatever power management stuff, which I just turned on in the BIOS again some days ago. So maybe 80, like Intel IG whatever, ICB, yeah. Still not power management stuff. So let's finish this. Compiler type is it ucore in function, call to compiler set, declared, build bug failed in, where is it even freaking? Build bug, compare exchange, not an expansion of macro build bug. Here, 138. Okay, apparently this is some, which file is it even? So this is some, exchange here, active false, okay. Exchange, so this appears to be a domain active. So this appears to be some Linux kernel portable C macro. Was it a macro? Which one even was it? Alternative? No. Only delivery. 1 second. Cheers. So they have there some size check, as we have seen. Apparently here, so that is a size, new size exchange relaxed. Where is the exchange? Maybe here, pointer new size. Is it even? Ah, here's exchange 32. Build bug on Arch exchange type of. So apparently the RISC-V stuff is more strictly checking than what even is x86 doing there. Isn't it truly portable if Arch exchange, no log prefix, even on SMP exchange always implies log anyways. This is generally used to protect other memory information. We use it on volatile and memory cloggers to prevent GCC from moving. Yeah, nothing like x86, nothing. Ah, yes, this is compare exchange. x86, nothing like even making C macro and stuff. So I don't immediately see that there though. Compare. Is it even? If, okay, the exchange active with false, and if this, where is active though? Domain active is domain. Where is struct domain? So obviously the size doesn't match, or something like that. Where do they even set this to true then? If exchange domain active. So if this previously was active when it is exchanged with false. Only need to make this build. So, okay, what does RISC-V do? I mean, it would be helpful to know where this domain, what size that is, maybe int. But it would be good to know. So struct as a promise might be a little bit. Was it an uncore? Appropriate power domain. Schedulist active game objects uncore. Where is it? Yada yada yada. Okay, maybe we check uncore. I believe it was uncore, wasn't it? Until uncore. Active. Bool active. Intel uncore force wake domain. Was it this one? Struct Intel uncore. Only thing I see here is that one. You would think bool should. Is it even that one? Okay, here's this uncore. Is it firmware domain? Probably firmware domain, huh? Where is this domain coming from? Here, Intel uncore force wake domain. Okay, I thought FW stands for firmware, maybe it stands for force wake. Container of timer, something timer, uncore. So that is of uncore force wake domain. Force wake domain enum. No, this can't be that one. Force wake range Intel. Here, Intel uncore. That is a struct inside Intel uncore. So yeah. So usually you would think it is int. Okay, I mean theoretically the types are sound. This is bool and this is false. Not really sure why should we explicitly int that or bool that? I have no idea. C programming for expansion of macro exchange. What exactly is this RISC-V macro doing here? Exchange. Size of pointer not 8. By the way, is that a... Do we pass in there a pointer? Where is even the freaking exchange? Because I don't see it. Okay, we pass in there a pointer, so... Where exactly does it bug on? Expansion of build bug in 138. Oh wait, is it even the... Was it compare exchange? It was compare exchange. 138 or what was it? Build bug. Are we still live? Oh, 0 frames. Pointer new size. By the way, do they have a... here is, by the way, atomic instrumented. So there is arch in expansion of Arch Exchange. Do we also have just Exchange? Also saw 2000 lines of atomic exchange instructions, right? 1886. 1880. Oh, sorry, wrong header. 1886. Okay, here's a exchange with arbitrary arguments. Pointer, type of pointer, underscore AI pointer. Instrument atomic write, AI pointer, size of AI pointer, Arch Exchange. So they then expand this to Arch Exchange with those arcs. This is why I didn't find it here. Arch Exchange is here. Type of no, you can't overcomplicate this stuff. C program, C amazing C program in 2023, right? And why people, how people still can defend this glorified assembler macro preprocessor thing is also beyond me. So type of this, okay, this is usually in parentheses because it might be other expressions. So guarding that, dereferencing the pointer. So type of Z, so Z is bool. Bool x equals, what is this? There should be bool x or not. Exchange pointer x. I'm a little bit confused what this is. It doing what is size of? Okay, so this is expanding the size of this dereference pointer, which should be a bool. What is the size of this bool? Wait, was there some? No, thank you very much. Why does this fail? I hate when the most trivial stuff. I mean, okay, the size is probably not 408, so could this be a character? Could this be 8 bytes? I mean, we could test that, changing that active. I mean, the best thing would be, so this is probably a pure in kernel structure. Let's test making this int. Int should be always 32-bit, shouldn't it? With int and long, we had long is the size of pointers, right? In Unix usually. It's different in Windows, by the way. Let's see what happens. I mean, we could make this in 32 thing, but it's not necessarily the most used in Linux kernel there. Hey, okay, it's rebuilding some stuff. Oh, oi, we built something. We built something. Boys and girls, get the RISC-V system and ARM system out. How many arrows do we have? Not many. mod post undefined ttm bo vm dummy. Okay, this might be okay-ish. You know, let's save the file again. Let's save it again so that everything recompiles. This is build systems usually only check the timestamps, and let's rebuild everything. So this mod post stuff might just be this other DRM stuff isn't built yet, because we built, like we developed with this Linux build system override, capital M equals some module directory for only building those, so that might have been okay-ish. Yeah, next is then, I mean, this is a really fast first rough proof of concept. It could totally oops and blow up and hold and catch fire. And obviously all of those changes need to be checked for correctness. And in general, it could in general totally not work and hold and catch fire. Yeah, but that's basically kind of what is needed. And in contrast to this previous, do we still have that? This is some bug of this. I'm running not the latest version of Wayland stuff. In contrast to this original patch, which is complete garbage, which is obviously also not why it wasn't applied. So theoretically, if you wanted to do that right, if you wanted to do that right, you would need to go through all the files and conditionally compile them for obviously it makes no sense to build all this integrated stuff for ARM and RISC where it never historically was and could have integrated unless some RISC-V processor stock vendor now licenses old integrated graphics from Intel, which probably will not happen, but theoretically, of course, there always could be the possibility. So unless someone really licenses decade-old graphics from Intel and puts this in a RISC-V stock, it will never be in one ARM or RISC-V stock. So it makes no sense to build all this code when it never could possibly be run. But that is a topic for another video. I'm not yeah, if you shall subscribe, Patreon, GitHub, sponsorship, and all the other good stuff in between, then leave me comments below. So there are still flash iCache PTE. So there are still some undefined mem copy from undefined. So this might be, so yeah, still some stuff to do, right? No surprise, like first party is over. Back to more work. And mem copy. So maybe I forgot there one. This was unaligned. Maybe I forgot probably mem copy from this one, probably, huh? Yeah, recurring theme don't do mem copy at home. That probably fixes that build error. And cannot reach non-void function. Oh darn, this was some bloody this is mem copy from, by the way, from how many test whether reads are supported use. So yeah, to test that, so they have unlikely test whatever something. So I guess they usually have fallback. I mean, we probably could, like static branch has move anti-q. So yeah, we could actually, it's like, yeah, not supported false. So it should fall back to this one, I believe, famous last words. And again, this should be more elegant. This should be completely patched out. I'm not doing that today. If you shall like and subscribe enough, then I will do that. Okay, 3 more to go, wherever those are coming from. Driver, GPU, DRM. Wait, we still have an 810? Really? Seriously? So, PC BIOS align resources. So, this probably was not defined. So, this is align Resources, PCI bus alloc. So what is... maybe this is a global. That is of course not ideal. What exactly PCI bus align resources? PCI bus align resource. Whatever that stuff does. Does not appear to be too widely used. Probably this scripts. PCI bus alloc resource. Bus rest size alignment 0, non-resource. Only in garbage drivers. Oh wait. What even was it? Bus alloc resource PCMCIA align. PCMCIA align. Mask offset map. Resource alignment requirements dot size align. PCI BIOS align resource. Resource T. Yeah, the devil is always. So this obviously will not yet work. No surprise there. Oh, this is what I wanted to. Align function. So the other platforms have there something. Except RISC-V. Fun. Isn't it fun to have the most? Do we have something for ARM? ARM here, BIOS 32. From Arch PCI 386, we need to avoid collisions from mirrored VGA ports. Other strains, other hardware, still external I/O cards only decode low 10 bits. Just copy that. Of course, we built for the one platform. I mean, maybe it builds already somewhat for. Let's check some PowerPC. Mirrored VGA ports, yada yada. Skip either, something, return start. I wonder if, can we pass in there, basically if we say we don't care about that. Should I copy that? What? Completely, not lit. Completely no PCI stuff? Not resource. Line F. Okay, there is PCI bus unlock region. PCI bus unlock from line F. Damn it. Which one was it? This one. Allocate resource. Allocate resource, alignment function. Can this be? Okay, so, if not alignment function, then simple align resource. That sounds good to me. It's actually what I wanted to check, if actually this handles not supplying there anything. Is that this one? Where are we? Yes. Did I? Oh no, I didn't. I mean, this is a little bit nah. Alloc PCI resource. Because most platforms have that, so RISC-V should have it. So we could, for now, like it probably should work for ARM and so on. Should and should, famous last words. 0 frames, amazing. What disabling AP, MR, whatever does to PCI. So if dev config RISC-V, then null, otherwise let's hope for the best. Only two left, only. But I'll probably continue this later, and then the question is, of course, how much does it hold and catch fire? Was it the best idea after all to want to run into dedicated graphics in your ARM and RISC-V? But hopefully you learned and enjoyed this and learned something. We probably, is this some integrated graphics only? Early quirks, resource into graphics stolen res. So we don't have that, I would think. Or should we check, was it? It might be a purely, also yeah, x86, you run Intel integrated stolen resource stuff. On each boot, whether you have A30, 45 and so on. Base isn't available in any register, we need to calculate that. Welcome Aaron. Questions there, what to contribute to the Linux kernel. I always recommend to do what you need and have fun, right? Makes no sense to do what other big mega corporations want. Like my general recommendation, maybe most fulfilling, most fun, just work what interests you most. This is really many stone sizes. What did we even grab for? Resource, stolen RSS, define 00. Okay, so this probably should only apply to Intel integrated stuff and also yeah, C compiling, right? It's probably not defined and whatnot, it compiles anyway, you just have their dangling thing of do we use that more than that? GTT, is it the only use? That is pretty silly that it only debug, is it only some debug? We will see if this would be a little bit silly, but whatever. If we didn't grab that wrong. No, it should still be into graphics stolen. Oh wait, I probably overlooked one. Also precise. I should probably more often grab for. Here's intent stolen resin. Gem stolen SMEM setup. I would hope so. I mean, it should be initialized to 00 if you don't have it. So. Stolen system. Maybe if dev config x86 and Is RMM this mem? What is RMM? Certainly ain't negative, is it? Can this only return a null pointer? I wanted to return ino system thing, but it returns a struct into memory region. We could pair that with bug on. I mean, it's I would think it shouldn't. I mean, the question is this used anywhere else? And that is all the code that could be fully removed. Okay, now we have only flush icache PTE. Leave in the comments below, do you think this will hold and catch fire? Bug on, or will it just work on the first try? How lucky are we feeling today? Don't forget to share, like, and subscribe. Why is this not in some source file? Okay, that comes through page table. Maybe this is not exported, so export symbol flush PTE. What do they have? Oh, they have this export symbol all over after each function. Okay, then flush icache PTE. Try that again. Yeah, I probably could make a poll on the other channel to see how, if it holds, catches fire, if it does something. I hope you enjoyed to learn something. And this is just the first path, right? The next would be, I mean, if you would be a professional Intel employee, you would actually think about all the quick hacks, bugs, and so on. In general, think about correctness and so on. Then see what experimental testing reveals, because what's not tested is broken. Hey, is that even freaking? How much did we mod push? And so the diff is just some 17 files change, 100 session stuff. I hope it's all. I now need to check if I really fix file diff each file, not that I lost precious editing here. Have a good day or night. Hope to see you soon. Don't forget to subscribe, and see you soon for all the next fun stuff and actually testing or finishing this to come.